Good morning everyone. This is second video regarding two methods for expressing the concentration of a solution. Okay, three methods for that expression already explained. It's a mass percentage, volume percentage and part per million. It's a ppm. Now we have a fourth method for expressing concentration of a solution. Okay, that one is molarity. So today I'll explain molarity and molality, two more methods to you, and both are very important for your exam point of view. Okay, now in this one, first one is molarity. Okay, molarity is represented by capital M. Now just see, it's a representation, it's a capital M. And again, your main concern is with definition as well as with formula, because in exam maybe question is only define molarity. So when definition is required, so you have to write definition, because you will get marks for definition, because question is define. Okay, now in this one, so what is molarity? So it is the number of moles of solute dissolved per liter of the solution. Okay, that one is molarity. So in this one, formula, number of moles of solute upon volume of solution in liter. Now in case maybe volume of solution is not given in liter, it's given in ml or maybe in 1000. So this one is multiplied by 100. Formula is same. Instead of number of moles of solute, you can write NB. It's a number of moles of solute, as I told you, solute. Okay, B is for solute and A is for solvent. So N is number of moles, here B is for solute. So NB upon volume means V. If it's not given in liter, okay, and it's given in ml and centimeter cube, so this is multiplied by 1000. This you have to remember, because otherwise your answer will be wrong. Now in this case, in this molarity, what's the unit? The unit of molarity is mole per liter, and instead of this you can write capital M. And because volume is given, so generally molarity changes with temperature. As temperature increases, volume expand, and if it decreases, then it contracts. Okay, so it changes with temperature. Okay, now next one is in this one. Okay, one more thing, one question rises, how to calculate number of moles of solute. Although number of moles of solute is easy, it's a old topic, but still again I'll tell you how to calculate number of moles. Now in case of this, when you have to calculate number of moles of solute, now suppose you have to calculate number of moles of solute, that's why I'm writing NB. So for this, one more formula, that one is given mass upon, either if atom is given, so you can write atomic mass, otherwise it's a molar mass, or you can say molecular mass. Okay, so if atom is given, so mass of that one, given mass upon atomic mass, or you can say molar mass. So with the help of this you can calculate number of moles. Okay, then volume, either volume is given to you directly, otherwise we have other formulas to calculate volume. For example, if density is given, so for that either mass or density is given, so in that case also we can calculate volume, because density is equal to mass upon volume. This is very important topic that you have to revise, learn. Now next thing is in this one, that one is molality. This one is another method, it's a molality. That one is represented by small m. And how to define it? So it is the number of moles of the solute dissolved per 1000 gram. Instead of this you can write per kg of the solvent, and the formula is number of moles of solute upon, this one is weight of solvent. Here weight of solvent in kg. Again, if it is not given in kg, so you have to multiply the whole formula with 1000. So this one is m is equal to nb upon wa. In, if it is not given in kg, maybe it is in gram, to multiply by 1000. Now unit of molality, it's a mole per kg, and it does not change with temperature. Why? Because weight is given, volume is not given, its weight is given, that's why it does not change with temperature. Now in this one very general question, molarity. Okay, now this very general question is that molality is considered better for expressing the concentration as compared to molarity. Why? Okay, now just see, this one is molality is considered better for expressing the concentration as compared to molarity. You have to explain why. Okay, actually in this one, main thing is, I think you know that molarity depends upon temperature because it changes with the temperature, but molality does not. Okay, the molality does not change with temperature, that's why it is considered better for expressing the concentration as comparison to molarity. Okay, now you have to learn both the formulas, and we have one more formula, that is relationship between molality and molarity. This one is it's a formula. Just see, relationship between molality and molarity, it's m is equal to 1000 m upon, okay, 1000 rho, this one is density, minus m upon mb. Okay, so this one is relationship between capital M and small m, means molality and molarity. Now one numerical I'll explain, then first of all you have to learn the formula, then I'll explain more numericals. Now in this, just see, 2.46 gram of NaOH are dissolved in water and the solution is made to 100 centimeter cube in a volumetric flask. Calculate the molarity of the solution. Now for your first work is, you have to write formula. What you have to calculate? You have to calculate molarity. We have a direct formula, number of moles of solute upon volume. Now just see, in this volume is given in centimeter cube, it means you have to multiply here with 1000. Done, formula written. After that, whatever is given to you, you have to write mass of NaOH. Okay, that one is 2.46 gram. Volume is given, okay, 100 centimeter cube. Okay, but you have to calculate, volume is given, but you have to calculate number of moles, and for number of moles, what is required? Given mass upon molar mass. So molar mass is also given. Molar mass of NaOH is 40. So calculate number of moles. It's a 2.46 upon 40. Answer is this one. It's a 0.0615. Okay, at least you have to calculate up to 3 places after decimal. Now in this one, okay, now put this value in these values in your formula. So therefore molarity is equal to 0.0615 upon 100 into 1000. Solve it. After that your answer is 0.615 m. This one is regarding to your numerical. Now one question is for you. You have to calculate it. It's almost same. Now just see, a solution is prepared by dissolving 18.25 gram of NaOH in distilled water to give 200 ml of solution. Calculate the molarity of the solution. Okay, it's a same pattern you have to solve. Okay, this one is your work. Thank you.